Hello my precious friends, I really hope that you are doing great. Welcome to our today's class. We are looking at a given Form 2 topic which is called indices. So let's start by looking at the laws of indices. So the first law of indices states that whenever you have a to the power of m, then you multiply by a to the power of n, then this should give you a to the power of the sum of those particular powers, so m plus n. The second law states that if you have a to the power of m, then you divide with a to the power of n, then this should give you a to the power of m minus n. The third law states that if you have a to the power of m, then into n, then this is the same as saying a to the power of m multiplied by n. Then the fourth law states that if you have 1 over a to the power of n, then this should be equal to a to the power of negative n. Then the fifth law states that if you have a to the power of 0, this one is always equal to 1. So you can add other laws. So let me add the sixth law, which states that if you have a to the power of m, then you multiply with b to the power of the same m, then this one is the same as saying a multiplied by b, then the whole thing we take it to the power of m. It's just like we are factoring out the power. Then similarly, if you have a to the power of m, then you divide with b to the power of m. This one is the same as saying a divided by b, then the whole thing we take it to the power of m. So these are the basic laws of indices. So the key thing is to note that whenever you multiply, if the bases are the same, then you are supposed to add the powers. Whenever you divide similar bases, then you subtract the powers, and so forth. So we look at an example of how we can apply these particular laws in real life. So we start with a past cases equation which was done in the year 1993, paper 2, question number 8. So the question reads that solve for x in 9 power x, then plus 3 power 2x minus 1 is equals to 53. So the first step, I'm going to take negative 1 towards the right hand side, so that I have 9 to the power of x, then plus 3 to the power of 2x. So this will be equal to 53 plus 1. So this will be 53 plus 1, of course, which will give you 54. But we know that 9 can be written as 3 to the power of 2. So this is 3 to the power of 2. Then, of course, we have x on the power here. Then plus 3 to the power of 2x. Then, of course, is equals to 54. So because 3 power 2x is common, I'll give it a letter. So I'll say let y to be equivalent to 3 power 2x, because 3 power 2x is common. So if I substitute, I'm going to get y, then plus y is equals to 54. So y plus y, I'll get 2y, which is equivalent to 54. Therefore, my value of y will be equal to 54. Then we divide it by 2. So if you take 54 divided by 2, you are going to get 27. So this gives us 27 as the value of y. But remember, the question did not ask us to find the value of y. The question wanted the value of x. So we'll come back to where we were saying we are letting y to be equal to 3 power 2x. So we were saying that let y be equal to 3 power 2x. So because we have already gotten the value of y, I'm going to substitute it here. So this will be, the value of y is 27, which is equals to 3 power 2x. Then we know that 27 is the same as saying 3 to the power of 3. So this will be 3 power 3 is equivalent to 3 power 2x. So because the bases are the same, I'm going to drop them. Therefore, I simply equate the powers. So this one means that 3 will be equivalent to 2x. Dividing through by 2, I'm going to get my value of x being equal to 3 over 2, or simply say 1.5, or simply 1.5. So that is our value of x. Then we look at the second example, which reads that solve the equation 9 power x plus 1 then plus 3 power 2x plus 1 is equals to 36. So this is also a past cases equation which was done in the year 1993, paper 2, question number 8. So for this particular question, I'm going to start by expressing a 9 to a base of 3, because I also have 3 to the power of 2x plus 1. So 9 is the same as saying 3 to the power of 2. Then of course I had x plus 1 on the power, so this will be into x plus 1. Then I add 3 power 2x, then of course plus 1, which should be equivalent to 36. So if I open the brackets on the power side, I'll have 3 to the power of 2x, then of course plus 2 times 1, you are going to get 2, then plus 3 power 2x, then plus 1, then of course this one is equivalent to 36. Then I'm going to reverse the laws. We were saying that if you have a to the power of m, then you multiply with a to the power of n, so this should give you a to the power of m plus, that is m plus n. So I'm going to rewrite this one here. So it's like I have 3 power 2x plus 1. So this is 2x plus 2. So if I reverse this law, it means that it was 3 to the power of m. My value of m in this case is 2x. So this was 3 power 2x, then multiplied by 3 to the power of 2, because the n in this case is actually 2. So to the power of 2. So this is how this part was. I'm also going to reverse this second part. I'm having 3 power 2x, then of course plus 1. So it means initially it was 3 to the power of 2x, then multiplied by 3 to the power of 1. So that when you multiply, you add the power so that you get the final answer. Now if I substitute those particular values in the original equation that I had, so 3 power 2x plus 2 was 3 power, it was 3 power 2x, then multiplied by 3 to the power of 2, multiplied by 3 power 2, then this was plus, so I'm going to add 3 power 2x plus 1, it was 3 power 2x, then times 3 power 1, so this is 3 power 2x, then of course multiplied by 3 to the power of 1, then the whole thing was equivalent to 36. So this one is equal to 36. So you can see that 3 power 2x is common here, it is also common here, so I'll give it a letter. So I'll let y to be equivalent to 3 power 2x. So if I substitute in this equation, I'm going to have y then multiplied by 3 power 2. Of course 3 power 2 is 9, then plus this will be y, so plus y then multiplied by 3 power 1, you'll get 3. So this is equivalent to 36. So this is 9y then plus 3y is equals to 36. So if you take 9y then you add 3y, you are going to get 12y being equal to 36. Therefore the value of y will be equal to 36 divided by 12, of course, which will give you 3. So 36 over 12, you are going to get 3. So if the value of y is 3, remember the question wanted us to solve the equation, and the unknown value in the equation was x. Therefore I'll take it back here. So you are saying that y is equivalent to 3 power 2x. So, and we have found that the value of y is 3. Therefore it means that 3 is equals to 3 power 2x. But remember 3 is the same as saying 3 to the power of 1, which is equivalent to 3 power 2x. So if I drop the bases because they are the same, I'm going to have 1 being equal to 2x. If I divide through by 2, I'm going to get my value of x as being a half, or simply 0.5. Then we also look at our third example. So our third example reads that find the value of x in the following equation. Our third example, find the value of x in the following equation: 49 power x plus 1 then plus 7 power 2x is equals to 350. So this is also a past cases equation done in the year 1995, paper 2, question number 5. So with this one, I'm going to start by breaking down 49 in terms of 7. So we know that 7 squared will give you 49. So 49 is the same as saying 7 to the power of 2. Then of course on the numerator, I had, that is on the power, I had x plus 1. So I'm going to add it there. Then plus, the second part is 7 power 2x. Then the whole of this is equivalent to 350. So remember, 350 cannot go into a form of 7 power something. That is why I'm not breaking it down. So if I open the brackets on the numerator, that is on the power side, I'm going to have 7 power 2 times x, I'll get 2x. Then plus 2 times 1, I'll get 2. Then plus 7 power 2x is equals to 350. Then I'm going to reverse the law here. Remember, when you have a to the power of m multiplied by a to the power of n, this should give you a power m then plus n. Now on this side, I already have my powers are already added, so I have 7 power 2x then plus 2 on this other side here. So it means initially it was 7 to the power of 2x then multiplied by 7 to the power of 2, so that when you add the powers, you get this value here. So if I rewrite this equation, I'm going to have 7 power 2x then multiplied by 7 power 2, then plus the second value here is 7 power 2x, 7 power 2x, then the whole of this is equals to 350. Now you can see 7 power 2x is common, so this is going to give me, I'll give it a letter, so I'll say let y to be equivalent to 7 power 2x. So this will be y then multiplied by, so this is y multiplied by 7 power 2 then plus, so 7 power 2x is also y, so this one is equals to 350. So this will give me 7 squared is 49, so this is 49y, then of course plus y is equals to 350. So this is equals to 350. So after getting 350, of course I'll add the like terms. So say 49y plus y, you are going to get 50y. So this will give me 50y. So I'm going to have 50y being equal to 350. Then of course I divide through by 50, divide through by 50. So I'm going to get my value of y being equal to, of course the 0 and 0 will cancel out, 5 into 5 1, 5 into 35 are 7 times. So my value of y is equivalent to 7. Then we had said that we are letting y to be equivalent to 7 power 2x in this step here. But the value of y is 7, so this one means 7 is equivalent to 7 power 2x. But 7 is the same as saying 7 to the power of 1. So this is equivalent to 7 power 2x. Therefore, if I drop the bases, I simply equate the powers. So this one means that 1 is equivalent to 2x. Therefore, if I divide through by 2, I'm going to get the value of x as being a half or 0.5. Then we look at our fourth example, which is also a past cases question done in the year 1996, paper 2, question number 9. So it reads, find the value of x which satisfies the following equation. So the equation is 16 power x squared is equals to 8 to the power of 4x minus 3. So if you look at 16 and 8, we can take it to base 2. So we can either take it to base 2. So 16 is the same as saying, so we can look for the factors of 16 here. So 16 by 2, 2 into 16, that is 8. Then of course 2 into 8, 4 times, 2 into 4, 2 times, then 2 into 2, 1. So 16 is the same as saying 2 power 1, 2, 3, 4. So this is 16 is 2 to the power of 4. Then I also have 8. 8 is 2 to the power of 3. 1, 2, 3. So 16 is 2 to the power of 4. Then we also had x squared on the same power, which is equivalent to 8. 8 is 2 to the power of 3. Then of course into 4x, then minus 3. So this will be 2 to the power of 4x squared being equal to 2 to the power of 3 by 4, I'll get 12x. Then 3 by 3, I'm going to get negative 9. So 12x minus 9. So because all of them are to base 2, I'm going to drop the bases. Therefore, I'll simply equate the powers. So this one means that 4x squared is equivalent to 12x minus 9. So these are quadratic equation. Therefore, I'll rewrite it as 4x squared, then minus 12x, then plus 9 is equal to 0. So I want to use a factorization method to solve it, but remember you can also use other methods, for example completing square, the quadratic formula, and so on and so forth. So if I use factorization method, I'll compare it with ax squared, then plus bx, then plus c is equals to 0. Therefore, the value of a will actually be 4, the value of b will be negative 12, then the value of c will be positive 9. So using factorization method, I need to find the product. The product is usually the value of a multiplied by the value of c, which is a is 4, the value of c is positive 9. So 4 multiplied by 9, we're going to get 36. So this gives you 36. Then we also find the sum. The sum is usually the value of b. So the sum is usually the value of b. In this case, our value of b is negative 12. So we look for two numbers. When you multiply, you get 36. When you add, you get negative 12. So to get that, we are going to look at the factors of the product. So we look at the factors of the product, which is 36. So by 2, I'm going to get 36 over 2 will get 18. So this will give us 18. So we have 18. Then by 2, we are going to get 9. Then of course by 3, you are going to get 3. Then by 3, you are going to get 1. So we need a combination that will give us 12. Of course, if you combine 3, that is 3 by 3, that one is 9. Then 9, if you add 9 plus 4, that one will give you 9 plus 4 will give you 13. So I need a different combination, so I can combine 2 and 3, so that because I know that 6 and 6 will give me 12. So actually the numbers in this case will be 6 and 6, but we have a negative in the sum, so I'll introduce a negative here, so that when I multiply 6 by 6, I'll get positive 36. If I add negative 6 plus negative 6, I'll get negative 12. So this will be 4x squared. Then where I have b, I simply substitute with the negative 6 and 6. So this will be plus, I substitute these two, minus 6, minus 6. Then I continue with the equation. So I have x, then plus 9 being equal to 0. Remember, for this case, we are simply substituting the value of b, because if you take negative 6 minus 6, you are going to get negative 12. So if I open the bracket, I'm going to have 4x squared minus 6x minus 6x, then plus 9 is equal to 0. So the common factor here, we have 2 is common, then x is also common. So 4x squared over 2x, 2 will go into 4 2 times, x will go into x squared, x times. Then minus 2 into 6, I'll get 3, then x will cancel out. Then I'm going to factor out a negative 3, so that it changes this to positive, because I have 2x, positive 2x here. So negative 6 over negative 3, you're going to get positive 2. Then of course we have x here. Then positive 9 divided by negative 3, I'm going to get negative 3. So this is equal to 0. Therefore it means that 2x minus 3, then I pick one of the values in the bracket, which is also 2x minus 3. This should give me 0. So because the roots are the same, this is what we call a repeated root. Therefore I just pick one of them. 2x minus 3 is equals to 0. So 2x will be equal to 3. Therefore the value of x will be equal to 3 over 2, or simply 1.5. So this is a repeated root. So that is my value of x. So in our next class, we'll be looking at further examples involving the same topic. Thank you very much. Until next time, this is Kind Tuition.